Why is fluid friction in pipes so counterintuitive? Imagine trying to push water through a pipe and finding that increasing the speed doesn't just make it harder, but sometimes causes a sudden jump in resistance. That's what makes fluid friction in pipes so puzzling. When you think about friction, you might picture rubbing your hands together or sliding a box across the floor. But fluid friction behaves quite differently. It depends on many factors like how fast the fluid moves, the size of the pipe, and the pipe's surface. One surprising thing is that friction doesn't always increase in a straight line as flow speeds up. When the flow is slow and smooth, called laminar flow, friction increases gradually. But when the flow becomes chaotic and turbulent, the friction jumps sharply. Doubling the speed in turbulent flow can cause more than double the resistance, which is not what you might expect from everyday friction. Another odd fact is how sensitive the flow rate is to the pipe size. The flow depends on the pipe radius raised to the fourth power. So, making the pipe just a little wider can drastically reduce friction and boost flow. This relationship is much stronger than the simple square or linear relationship seen in other physical phenomena. It's like a small change in pipe size can have a huge impact on how easily water flows through. Friction also depends on things like pipe bends, fittings, and rough surfaces. These create turbulence and energy loss in specific spots, making the flow even more unpredictable. It's not just about the pipe itself but how everything is connected and shaped. This makes predicting flow behavior tricky without detailed calculations. From an energy point of view, friction turns some of the mechanical energy into heat inside the fluid. This tiny temperature rise is often overlooked but important in real systems. It's a subtle effect that can influence how systems are designed. In practical engineering, understanding these counterintuitive behaviors helps in designing better piping systems. Using slightly larger pipes or smoother surfaces can cut down on energy costs. Avoiding sharp bends and rough fittings keeps the flow smoother and saves power. So, the reason fluid friction in pipes seems so strange is because it involves nonlinear relationships, high sensitivity to pipe size, flow regime changes, and energy transformations. These facts make analyzing pipe flow a fascinating challenge, but also a key part of creating efficient fluid transport systems.